Hi everyone, I am Megha Jain. I'm a program manager on the Windows graphics team. And I've been with Microsoft just 3 years, but all those 3 years I worked on the same team, which was responsible for building the highest quality and high performance 2D graphics. In the past 2 days, starting with the keynote itself, you guys must have heard a lot about how your MetroStat application is hardware accelerated by default. It doesn't matter what technology you choose for development, whether it's HTML5 with JavaScript, or it's XAML, or you're using C++, C#, it's all powered by DirectX. But if you need more control and maximum efficiency, you need to go down to the basics and work with DirectX. So my talk today is going to focus on how your 2D graphics application, which is MetroStat application for Windows 8, can be built with the fastest performance possible. Oops, I should have started with this one, but. So there are 3 main things I'm going to talk about. The first thing is basically do a comparison of the same application running on Windows 7 system and a Windows 8 system, and how the performance, the baseline performance itself is faster for Windows 8 PC. And then have a little conversation around the fact that if things are already fast, what are the scenarios in which you might not be happy with the performance that you're getting? And then finally, what are the techniques and tips you can use to actually get the performance that you really want for your app? So let's get started. So as I said, basically the baseline performance itself in Windows 8 is much faster compared to Windows 7. And I have like a small demo here just to demonstrate that. And I'm going to switch to the demo machine really quick. So this is a very simple sample that we have in the build image that you guys have, and you can play around just a little bit with it. Like you can pinch to zoom in, zoom out, and you can move the text around. So basically, the point that I want to get through this app is that we took a very similar application that had a lot more text than what I just showed, and we took some measurements of the Windows 7 incarnation of the application and the Windows 8 version, and here are some numbers. Basically, the same app ran almost 2x faster on your Windows 8 system. Let's take another example. So here what I have is like almost 512 geometry primitives that are rendering, and I can increase the number of primitives. I can do a bunch of other stuff as well. But basically the idea is that you have lots and lots of primitives that are rendering. Just one second. You have lots and lots of primitives that are rendering, and again, we did a comparison of the Windows 7 incarnation of the same sample and the Windows 8 version, and with the increasing number of primitives. And basically, as you can see, again, we've done a lot of work in our geometry pipeline to make it much faster in Windows 8. The message that I'm trying to land here is that your existing applications are going to run much faster on the Windows 8 system, so which is great. And so far what I showed, like all the other 2 samples were, the first one was very text focused and the second one was very geometry focused, basically just rendering the same sort of primitive. And in a real world scenario, you might have more stuff. For instance, this is again a sample that's available to you in the build image, and I need to switch the demo machine. And in the sample, you have like pretty looking text that you can scroll. There's a bitmap in the back, and there's some rectangles, and there is a glow around the butterfly, and it also utilizes some new direct features like kerning, and there's like some embedded font. And you can like touch it, and the response is really good. So basically, the reason why I show this app is because when we started building this application, in the first naive version of this application, the text, when I was scrolling it really fast, wasn't able to re-render and keep up, and it was a little jittery. So basically, there are situations in which you might not get the performance that you want. In this case, I wasn't able to get very smooth scroll that you actually saw in this sample. So we did some work to make it fast, and the rest of my presentation is basically going to focus on scenarios and then advice or recommendations for how to make the scenarios fast. These are the 6 scenarios I'm going to talk about, and you don't have to look at all of them right now, but we can start with the first one. So if you have a complex scene and you want to animate it, what are some of the techniques that you can use to make it really fast? For instance, in the Grasshopper app that I just showed, in which there was scrolling text, we used one of the techniques here. So the technique is caching, and the basic idea behind this technique is that instead of drawing all the primitives every frame within, like if you guys are familiar with Direct2D between big and draw constructs, you instead draw it to an intermediate bitmap and then draw that bitmap again and again, because bitmap drawing is much faster. And there are 2 ways in which you can do caching. Either you can cache your full scene. Say, for instance, the magazine app that I showed, it had a lot of mixed content. There was a geometry, there was bitmap, lots of text. So I was caching all of that content in a bitmap. If you just have, say, text, lots and lots of text, or if you just have geometries, you can use another technique, which is basically just render that into a bitmap, and it works a little differently. And I'm going to show both of these techniques with some code snippets. So full scene caching, basically the way you start is that you create your bitmap, and the important thing here is that the bitmap that you're creating is a full color bitmap. In this case, I'm creating a BGRA bitmap. And then if you guys attended yesterday's talk about building application with DirectX, there was some conversation around how we've changed certain objects in Windows 8. That is, render target somehow is factored into device context that has like a lot of state, and then you do the drawing, and you can change the bitmap on which you draw dynamically. So basically here what I'm doing is that once I've created my bitmap, I basically save the contents of my current bitmap, which is associated with the display. In this case, I'm calling it the old target. And after saving that, I set target to the bitmap that I just created, which is, in this case, I'm calling it a scene bitmap, and then draw all the drawing between big and draw block. Once I'm done with drawing, I set the target back to my old target, which is associated with the display, and then instead of drawing all the primitives, I simply draw the bitmap again. The per primitive way of doing caching is based on an API called fill opacity mask, and I'll get to that in a minute. It's a little more complex than using a full scene. I shouldn't say complex. It's a little more sophisticated than using the full scene caching technique, in the sense that you can change the color or the brush with which you are drawing dynamically. So it's basically independent of the bitmap in which you're making all the drawing. And here is some code snippet for that. So just as in the previous case, you create a bitmap, the difference being that instead of creating a full color bitmap, you create an opacity bitmap, and the format for this is A8, which basically means that it only has opacity information and no color information. Same as the old case, I save my current drawing and then set the target to this opacity or scene bitmap and do all the drawing here. And then once I set my target back to my display bitmap, instead of calling draw bitmap, I make a call to an API called fill opacity mask. This API will take the bitmap in which you did all your drawing, the brush with which you want to fill all that content, And the type of content also you can specify. Say, for instance, the demo that I showed with animating geometries, there's also an incarnation of that particular demo available in the samples where I use this per primitive caching technique. And there I specify the content type as graphics. If you want to cache text, then you can specify the content type as text. They're just internal optimizations that kick in if you do that. So since I'm talking about animations and complex content, I'll take a little minute and talk about something for scroll animation. So in DXGI, we have added a new function called present1 that takes a struct, which has basically 2 parameters that can help you in making your scroll animation faster. It basically enables you to specify a region, a rect, which is only that rect is updated every time you're scrolling instead of re-rendering your whole scene. What's printing doing here? Well, I thought I should talk about printing because it's new in D2D and it's awesome. But apart from that, there's also another reason, because it uses the caching technique. So it's not related to animation because you're not printing animations, but since it's also based on the technique of caching, I thought I should talk about printing here. So you don't want to use any of the caching techniques that I just talked about for printing because they'll be really cost prohibitive in terms of memory because it's bitmap. You don't want to rasterize your content. So for that purpose, we have introduced a new construct in Direct2D called command list, which helps you in caching all the content that you can use for primitive, or that you can use for the display path. Even though it's a different construct, it's very similar to using a bitmap, and the API is very consistent, both for the display path and for the print path. The trade-off is in terms of which path you want to optimize. The way a command list works is also, again, very similar to a bitmap in the sense that instead of setting the target to a bitmap, you set the target to a command list, and then you record all your commands, or you do all your drawing within begin draw, end draw block, just the way you'll do with a bitmap. And what the command list does is that it preserves the vector content. It does not rasterize the content then and there. You can pass this command list construct to your print control, and it will delay the rasterization till as late a stage as possible. So basically, when you are animating complex content, or if you're not getting the frame rate that you desire for your content for the display path, you want to use one of the 2 bitmap caching techniques. And for print output, you want to cache it using the new command list construct. Okay, we're back to our 6 scenarios. The second scenario, and I think it's also very common, which is a lot of times you want to clip your content, your scene, to an arbitrary geometry. For example, in this case, a really cute koala wants to look even fancier, so I apply this geometry to it, and yeah, I think it's happier like this. So the one way in which you can do it is you can use a layer construct. A layer construct is not new in Windows 8. We had it in Windows 7 as well. You create a layer, and you push a layer, and you also pass in the geometric mask, which is basically the geometry to which you want to clip your content. Then you draw all your content, and once you push your layer, it gets clipped, your scene gets clipped to the geometric mask that you pass. Now, since the API surface is really big, there could be multiple ways in which you can implement the same scenario. In this case, instead of using a layer, I could have created an opacity bitmap just the way I showed in using per primitive caching, and then create an opacity brush from that bitmap. And then on my D2D device context, make a call to fill geometry by passing in that bitmap and the brush with which I want to fill it, and the opacity and the geometry with which the geometry that I want to fill. So what this says is that if I have multiple ways in doing something, I need to choose one path. In this particular case, you probably want to use layers because we have done a lot of work in Windows 8 to optimize layer rendering. And there's another thing is that we have also introduced a concept of a null layer. So in this example, instead of creating the layer yourself, you can totally skip that step and directly push a layer and pass in null. What this means is that you're not responsible for managing the layer resource. You are letting Direct2D manage the lifetime of that resource for you, and we'll try to do it in as efficient a way as possible. Another thing is that if you're clipping to not an arbitrary geometry and just a simple axis aligned clip, there is an API in Direct2D called push axis align clip that is even faster than layers, and that's what you want to use if it's just a simple axis align clip and not an arbitrary geometry. Text. Text is ubiquitous. It's like everywhere. And we've done a lot of optimizations, as you guys see, but it's never enough for text. You always want something more. So there are 3 things that you can keep in mind to make things faster when you're dealing with text. So first thing is caching text layout. Before I talk about that, I just want to recap that there are 3 APIs in Direct2D with the help of which you can render text. It's draw text layout, and draw glyph run. You never want to use draw glyph run unless you are dealing with like individual glyphs and you want to write your own custom text renderer. So that leaves us with 2 choices, unless you're doing something really complex, which is draw text and draw text layout. Now, draw text is really simple and it's very easy to use, but it creates the layout every frame, and that might add a cost that you don't want. So what you can do instead is that you can create the layout yourself. And for doing that, you'll have to use the Direct2D API. You'll have to create the Direct2D factory and then create a text layout outside of your rendering code. And then when you're drawing the text, you should make a call to draw text layout and pass in the already created text layout. We've also done a bunch of work in Windows 8 to the type of text that you see is anti-aliased, and it's grayscale anti-aliased. And if you're working with Direct2D, we also expose the 2 new modes with which you can do grayscale text. And for your Metro style applications, in almost all the scenarios, you get grayscale text by default. But there are certain scenarios in which you might not get that. For instance, if you're creating a device context with the alpha mode set in D2D to null, which you might need because it makes it faster, and if you're not dealing with opacity, in that particular case, you will not get grayscale by default, and your text might not be as fast as you're expecting. So in that scenario, you want to explicitly set the text anti-alias mode to grayscale, and that might make things a little more faster. And then finally, you can choose one of the caching techniques that I already spoke about, depending upon whether you have mixed content or just text. We're almost halfway through here. So right after my talk, Shriram is going to talk about the new effect pipeline that we have added to Direct2D, and you can add a lot of cool effects. And I have a couple of tips, even before you know about effects. So let's see how good of a job I can do with that. So there is a new interface in Direct2D called ID2D1 properties interface that basically lets you set a bunch of effect properties. And one of those properties lets you cache the output of that effect. The way the entire pipeline works in a very naive way is that you have a bunch of outputs, and there's a black box, and then you have an output. That black box is basically you can add a bunch of effects, and those effects can be linked together to have a very complex graph of effects to get the ultimate effect that you want. So sometimes it can take a long time for execution of that effect graph. And if the output of that effect graph isn't changing every frame, then you can set the effect output cache value to be true, and then the graph will not be executed per frame, and you can get better performance out of it. The second technique to make not just effects actually, but in general, a point to keep in mind when you're rendering is that you should try to, whenever possible, have similar type of content rendered together. For instance, in this case, I have 4 buttons, and there's a slide glow effect and the text of that button. The button is represented itself by a rounded rectangle. Now, one approach of drawing this would be to simply draw individual buttons one at a time. So say I draw button 1 text, I draw the rounded rectangle boundary for it, and then the glow, and then I repeat it for the other 3 buttons as well. Well, you can do that, but it might be slow. What you probably want to do is that maybe start with drawing all the effects first, and then draw all the geometry and all the text. What this lets Direct2D do internally is coalesce similar types of commands together and is basically optimized. So whenever possible, you want to club similar types of primitives together and render them as a group. So all of you guys got like the Nike tablet, which has an amazing GPU. But apart from the amazing GPU, it also has a really good CPU. What Direct2D in Windows 8 lets you do is not just take advantage of the great GPU, but also scale the performance of your application based on the number of cores you have on your CPU. How do you do that? So when you're creating the D2D device context, there is an option where you can opt into enabling multi-threaded optimizations, which will let you take advantage of this feature. The reason why we don't have this enabled by default is because it does incur a small memory penalty per core, and that might not be something that you want. So it's a trade-off. It's almost like about 1 MB per core, which is not a lot, but it depends upon your application and the scenario. So if the only thing you care about most is frame rate, then you should, when creating a device context, you should go and enable this flag. And lastly, basically, all the DirectX APIs are meant to be to work very well together, but there could be scenarios, again, in which you don't get the performance that you want. For instance, if you're mixing 2D and 3D content together, like this sample that we have, it's a simple 3D game sample in the build, and this is just a snapshot from that. And the scene is 3D, and there's overlapping 2D text on top of it. So in a scenario, in a scenario where you have 2D and 3D content together, instead of mixing 2D and 3D possible, you should try, again, as I said before, group all the 2D commands together and group all the 3D commands together. What this lets you do is reduce the state transition. And every time you're transitioning from 2D drawing to 3D drawing or the other way, there's a state transition which incurs some cost. So as much as possible, minimize that. And this point is also true if you're just drawing 2D content, and if you are, say, dealing with lots of intermediates. You don't want to keep switching between the intermediates because internally it does incur a state transition. So you want to minimize basically setting the targets repeatedly, or when drawing 2D and 3D together, minimizing the transitions between them. So these were the 6 scenarios and some techniques that we talked about today. And basically what I want to say is that when you start writing your application, write it the way you want it. If you don't get the performance that you expect, profile, figure out what's wrong, and then try to use some of the tips and techniques that we just talked about here. And this is a list of other graphic sessions that you might be interested in looking at. Right after my session is the session which is for creating cool image effects with Direct2D. So if you want to learn more about that, I would recommend just staying here. And last year, I gave another very similar talk on optimizing your 2D graphics application with Direct2D on Windows 7. And there is another PDC talk the year before, which is also focused on performance. Almost all of that advice is still applicable, so I would strongly encourage that you can go and take a look at those talks as well to learn more. With that, I'll say thank you, and I'll open for questions. We have like